Hey guys, welcome back to Striking Studies. So today we're going to be doing Force and Laws of Motion Part 3. So we did Newton's first law of motion in Force and Laws of Motion Part 1. And if you didn't watch that, go back and watch that and then come here. So according to the second law of motion, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So now this is basically a very complicated way of saying F equals ma, where F is the force, m is mass, and a is acceleration. So force equals mass into acceleration, and this is very important because it comes everywhere, literally. Not in real life though. And now we're going to go through the applications and results of Newton's second law of motion. So now, suppose a lightweight vehicle, say a small car, and a heavyweight vehicle, let's say a loaded truck, are parked on a horizontal road. A much greater force is needed to push the truck than the car to bring them to the same speed in the same time. This is because for a given interval, the force is directly proportional to the change in momentum. Here, the change in momentum of the truck is quite large than that of the car. Therefore, force required for truck is quite large as compared to that for the car. So, the second example is an experienced cricketer catches a cricket ball coming in with great speed far more easily than a beginner who can hurt his hands in the act. One reason is that the experienced one allows a longer time for catching the ball, and the force with which the ball hurts his hand decreases. As a result, his hands are not injured. A beginner, on the other hand, keeps his hands fixed and tries to catch the ball almost instantly. Thus, a much greater force is exerted by the ball on his hands, and this hurts him a lot. The third example is if two stones, one light and the other heavy, are dropped from the top of a building, a person on the ground will find it easier to catch the light stone than the heavy stone. This is because force is directly proportional to the mass of an object. Now, we're going to just do impulse of force. So, we often have to work with forces which have very large magnitude but which act for very small time intervals. For example, when a ball rebounds from hard floor, it remains in contact with the floor for a very short time. The ball exerts a large force on the ball. The floor exerts a large force on the ball in this short time. Such a force is called impulsive force. Although the force is very large and the time is very short, their product, the impulse, remains finite. Thus, an impulsive force produces a finite change in momentum. Impulsive force is known by the letter J, and J is equal to Ft, where F is force and T is the time period. So that's also an important formula in exams only, not in real life. And this time, instead of a fact of the video, I'm going to give you a question of the video and you can comment down your answer. What is Galileo's full name? So that's the end of part 3. If you like this video, don't forget to like it, share, subscribe, and comment down below answer and also how this video was. Bye guys!